Good day, everyone. Today, we will have the review in the concepts of elementary algebra, and our basis will be the 50 review items that I just provided. I will be your review master, Sir Aldrin M. Manlusok. For item number 1, let's have this question. Which of the following equations is inconsistent equation? A. 4x is equal to 4x. B. 3 quantity x minus 4 quantity is equal to negative 4 quantity 1 minus 3x quantity. C. 2 minus 4x is equal to negative 4x minus 1. Or D. 2 over 3x plus 3 is equal to negative 7 over 2x. To answer item number 1, first we need to define inconsistent equation. Inconsistent equation is an equation whose solution set is the empty set. Then by solving one of the options, 2 minus 4x is equal to negative 4x minus 1. Then we use the addition property of equality wherein we transpose one term to the other sides of the equation, making both sides of the equation with similar terms. That is, we have negative 4x plus 4x is equal to negative 1 minus 2. Then by simplifying, we will end up with 0 is not equal to negative 3. Thus, there is no solution or an empty set for the equation. And it qualifies option C, 2 minus 4x is equal to negative 4x minus 1 as an inconsistent equation. And that is our correct answer. Next question, item number 2. Which of the following equations is identity equation? A. X plus 2 is equal to x minus 2. B. 4 quantity x minus 5 quantity is equal to negative 4 quantity negative 5 plus x quantity. C. X squared minus 49 is equal to 0. Or D. 2x over x is equal to 2. Identity equation is an equation that is satisfied by every number by which both sides of the equation are defined. The number of solutions is infinite. By solving one of the options, 2x over x is equal to 2, we can simplify this by simply having the cross multiplication of 2x with 1 here. Then we have 2x here. Then we have x multiplied with 2 here. Then we have 2x also. As you can see, we have both sides of the equation the same. Then we can also extend this by dividing both sides by 2x. Then we end up with 0 is equal to 0. Meaning, the solution is infinite. Then, by having this option D, 2x over x is equal to 2, it qualifies to be an identity equation, which is our correct answer. Item number 3. Simplify. Negative 1 quantity, negative 2 quantity, negative 51a divided by 17 plus 4 quantity minus 3a quantity minus 17a quantity is equal to blank. The options are A. 13a, B. Negative 13a, C. 47a, D. Negative 47a. In simplifying series of operations, we follow the GERMDAS rule. GERMDAS is an acronym that stands for G. Groupings. Groupings includes parentheses, brackets, braces, and the fraction bar. E stands for the exponents or powers. Then we have to have radicals and roots, that is our R. Then we have M or D stands for multiplication or division. Then the A or S, addition or subtraction. We need to take note that if we simplify groupings, we start simplifying the innermost as we go on the outermost. Then in exponents and powers, always remember the laws of exponents. Then same as true with extracting the roots. In multiplication or division, we need to take note that these are same level operations. Then we need to simplify the one that is on the left side first before we go on with simplifying on the right. If division exists first on the left, then we divide first before we multiply. Same as true with addition or subtraction. In the case of this, we need to simplify the one that is on the left before we simplify the one that is in the right. That is, if we have subtraction on the left side first, we subtract the numbers or the terms first before we move on with adding on the right. Okay, going back with our question, -1, quantity -2, quantity -51a divided by 17 plus 4 quantity -3a quantity minus 17a quantity. In this case, we start simplifying the one that is in the innermost. As you can see, we have parentheses here, but nothing to do with the simplification in the inside. So, we need to consider the one that is on the left. So, since division exists first before multiplication, we need to divide -51a by 17 first, and that is, we have a quotient of -3a. Then we have to multiply 4 and -3a, ending up with the product which is -12a. Now, since we only have the subtraction as the operation, we perform it as to simplify the expression in the bracket group. So we have -3a minus 12a equal to -15a. Since nothing is to be simplified in the inside, we are going outside by having it multiplied with -2. That is, we have a product of positive 30a. And in the braces group, we are simplifying 30a and 17a with the operation subtraction. 30a minus 17a will give us 13a. Since nothing is to be simplified inside the braces, we are going outside by multiplying it with -1. And our final answer will be -13a. Therefore, option B, -13a, is the correct answer. Item number 4. What is the simplest form of the expression quantity 5 quantity m plus 2 quantity minus 3m quantity minus quantity 3 quantity n plus 2 quantity minus 7 quantity n minus 3 quantity? The options are A, -2m plus 4n minus 17, B, 2m plus 4n plus 17, C, 2m plus 4n minus 17, and D, 2m plus 4n. Given A, B, and C are rational numbers, in simplifying A quantity B plus C quantity or A quantity B minus C quantity, we use the distributive property. That is, A quantity B plus C quantity is simply a multiplication of A with the terms inside the parentheses. That is, A multiplied with B, that is AB, then plus A multiplied with C will be ABC. Similarly, if we have A quantity, B minus C quantity, we end up with AB minus BC. Always remember, if we use distributive property, you apply also the Germdas rule as to simplify the expression. Going back with our item, quantity 5 quantity m plus 2 quantity minus 3m quantity minus quantity 3 quantity n plus 2 quantity minus 7 quantity n minus 3 quantity. In here, we are seeing two bracket groups. Then, inside of it, we're going to apply the distributive property. So, in 5 quantity m plus 2, we distribute 5 with all the terms. 5m, then 5 multiplied with 2 will be 10. Then similarly, we do the same thing. 3 multiplied with 2 plus, with n plus 2, we have 3n plus 6. Then negative 7 with n minus 3 will be a negative 7n plus 21. Now we move on with simplifying the insides of the bracket. We combine like terms. We have 5m minus 3m will be a 2m plus 10. Then in here, 3n minus 7n will be a negative 4n. Then a 6 plus 21 will be a positive 27. Now, since we have a subtraction here, we change the sign of the subtrahend. Then we proceed with addition. So, negative 4n will turn into a positive 4n, then a positive 27 will turn into a negative 27. Now we move on with combining like terms. So we have 10 minus 27 ending up with negative 17. Then with the remaining terms, our final answer will be 2m plus 4n minus 17. Therefore, our correct answer is option C, 2m plus 4n minus 17. Item number 5. The product of quantity 2a minus 3b plus 4c and quantity 2a plus 3b minus 4c quantity can easily be obtained if terms were regrouped as A. Quantity 2a minus 3b quantity plus 4c quantity and quantity 2a plus 3b quantity minus 4c quantity. B. Quantity 2a minus 3b quantity plus 4c quantity and quantity 2a plus 3b quantity minus 4c quantity. C. Quantity 2a minus quantity 3b plus 4c quantity and quantity 2a plus quantity 3b minus 4c quantity. And D. Quantity 2a minus quantity 3b minus 4c quantity and quantity 2a plus quantity 3b minus 4c quantity. With the given quantity 2a minus 3b plus 4c quantity and quantity 2a plus 3b minus 4c quantity, remember that in terms of finding the product of expressions, always keep in mind the special products. As we group them, observe possible special products, especially if the expression has two or more terms. In this case, we are going to use the product of sum and difference. That is, quantity A minus B quantity A plus B quantity is equal to A squared minus B squared. Okay? As we look at the given, we can see that we can group 3B and 4C in each parenthesis group. Okay? Now, as we factor out negative here, the positive on the 3b and 4c will turn into a negative or a minus. That is similar with or the same with the 3b minus 4c on the other group. Now, you can see that we have the same first term, 2a, and we have the same second term in group, 3b minus 4c on both bracket groups. That is, we use the grouping in the product of sum and difference. Therefore, we can easily find the product by squaring the first term and the second term, having the operation minus. Hence, the correct answer is option D, quantity 2A minus quantity 3B minus 4C quantity, and quantity 2A plus quantity 3B minus 4C quantity. Item number 6. What is the product of 4n m squared, quantity 3n m cubed, minus n squared m squared plus 4n quantity? The options are A, 12n squared m to the fifth power minus 4n cubed m to the fourth power plus 16n squared m squared. B, 7n squared m to the fifth power plus 3n cubed m to the fourth power plus 8n squared m squared. C, 12m to the fifth power minus 4n cubed plus 16m squared. Or D, 12n squared m to the fifth power plus 4n cubed m to the fourth power plus 16n squared m squared. In finding the product of monomial and multinomial or polynomial, use the distributive property and apply the laws of exponent. Some of the laws of exponents are the following. If m and n are integers and a is not equal to 0, then quantity a raised to m, quantity a raised to n quantity is equal to a raised to m plus n. That is our product law. Next one will be quantity a raised to m, quantity raised to n is equal to a raised to mn. That will be our power of a power law, where we can apply it in our item. If we multiply 4n m squared, quantity 3n m cubed, minus n squared m squared plus 4n quantity, we use the product law in each term. That is through the distributive property. Then we end up with 12n squared m to the fifth power minus 4n cubed m to the fourth power plus 16n squared m squared. Thus, the correct answer is item A. Item number 7. What is the quotient of quantity negative 12n m cubed minus 16n squared m squared plus 8n cubed m to the fourth power quantity divided by 4n m squared? The options are A, negative 3m plus 4n plus 2n squared m squared, B, 2n squared m squared minus 4n minus 3m, C, negative 8m minus 12n plus 4n squared m squared, or D, negative 3m minus 4n plus 2n squared m squared. In finding the quotient of multinomial or polynomial and monomial, divide or write in lowest terms the numerical coefficients and apply the laws of exponents. The following are the laws of exponent to be used. If m and n are integers and a is not equal to 0, if m is greater than n, then a raised to m over a raised to n is equal to a raised to m minus n. If m is less than n, then a raised to m over a raised to n is equal to 1 over a raised to n minus m. But if m is equal to n, a raised to m over a raised to n is equal to a raised to m minus n equal to a raised to 0. Since m and n are the same, then an a raised to 0 is simply equal to 1. Now, let's divide. Quantity negative 12n m cubed minus 16n squared m squared plus 8n cubed m to the fourth power quantity divided by 4n m squared. We are dividing the numerical coefficients with the numerical coefficient in the divisor. That is 4. Negative 12 divided by 4 will be a negative 3. Then with the loss of exponent, we have m. Then we have negative 4n plus 2n squared m squared. Hence, the correct answer is option D, negative 3m minus 4n plus 2n squared m squared. Item number 8. When x raised to 7 minus x is factored completely, it is equal to, options are A, x quantity x squared minus 1 quantity x to the fourth power plus x squared plus 1 quantity. B, x quantity x minus 1 quantity x plus 1 quantity x to the fourth power plus x squared plus 1 quantity. C, x quantity x minus 1 quantity x plus 1 quantity x squared plus x plus 1 quantity x squared minus x plus 1 quantity. Or D, x quantity x minus 1 quantity x plus 1 quantity x squared plus x plus 1 quantity x squared plus x plus 1 quantity. In factoring polynomials, check for the greatest common monomial factor first. If there is, then factor it out. Then proceed with the factoring. Some of the factoring combination are the following. A squared minus b squared is equal to quantity a plus b, quantity a minus b quantity. A squared plus minus 2ab plus b squared is equal to quantity a plus minus b quantity squared. A cubed plus minus b cubed is equivalent to quantity a plus minus b quantity a squared minus plus ab plus b squared quantity. Or you may use factoring of quadratic trinomial using the AC test. Now, to factor completely x raised to the 7th power minus x, we check for the greatest common monomial factor. Then we can see that the greatest common monomial factor of the two is x. Then the remaining terms will be x raised to the 6th power minus 1. And by using power product law, we factor out the powers in x raised to the 6th and in 1. So we have x quantity x cubed quantity squared minus quantity 1 cubed quantity squared quantity. With that, we can see that we can use this one. Okay, the factors of the product of sum and difference. So we factor it out. Then we have x quantity x cubed plus 1 quantity x cubed minus 1 quantity. Now, we may use the factoring patterns in a cubed plus minus b cubed. And here it is. Then we have x quantity, x plus 1 quantity x squared minus x plus 1, quantity, x minus 1, quantity, x squared plus x plus 1 quantity. And we arrange our answers with a monomial, binomials, and trinomials. Then our final answer will be option C. X quantity x minus 1 quantity x plus 1 quantity x squared plus x plus 1 quantity x squared minus x plus 1 quantity. Item number 9. Which of the following is equivalent to negative 3x plus 2 all over 4 minus 3x? The options are A. 1/2, B. 3x minus 2 all over 3x minus 4, C. 3x minus 2 all over negative 3x plus 4, or D. Negative 3x minus 2 all over 3x plus 4. In simplifying rational expressions, rearranging the terms in the numerator or denominator part might reveal the terms to divide to have it in the lowest term. Say for example, we have negative 3x plus 2 all over 4 minus 3x. It is simply equal to negative 3x plus 2, and if we rearrange the denominator, we can have it negative 3x plus 4. Now, with that, we try to factor out the negative 1. So, we have negative quantity 3x minus 2 quantity on the numerator. Then, for the denominator, we have negative quantity 3x minus 4 quantity. With the two negatives, we can have it cancelled. Okay? Then, it leads into this simplest form. We have 3x minus 2 over 3x minus 4. Always remember that we cannot divide numerical coefficients of binomials or multinomials if it is not a GCF, or the greatest common factor of the terms in the numerator and denominator. With that, the correct option is B, 3x minus 2 all over 3x minus 4. Item number 10. Which of the following sets of ordered pairs defines relation as a function? A. Set containing the ordered pairs 3, 2, 4, 3, 5, 2. B. Set containing the ordered pairs negative 1, 2, negative 1, 4, 2, 0. C. Set containing the ordered pairs 4, negative 1, 4, 0, 4, 1. Or D. Set containing the ordered pairs pi 2, pi 0, 0.52. A function is a relation that assigns to each member of the domain exactly one member of the range. That is, an x-coordinate should be paired with any of the element in the range containing the y-coordinates. We have this first example. So, in our first example, we have the ordered pairs 1, 3, 4, 5, and 8, 8. In this case, we are determining the correspondence of x coordinates to y coordinates. We have 1 paired with 3, 4 paired with 5, then 8 paired with 8. Meaning, one assigned x value or x coordinate is paired with different y coordinate. Then, there is a one-to-one correspondence between the members of domain and members of the range. Hence, this example qualifies to be a function. Okay? Next, let's have the set containing the ordered pairs negative 2, 8, 0, 2, 0, 5, and 1, 3. In this case, we can observe that 0 is used and paired with a different y coordinates twice. So we have 0 paired to 2 and 0 paired to 5. Meaning to say we have a one-to-many correspondence which violates the definition of function. Hence, it is just a mere relation. Okay? Next one, we have the set containing the ordered pairs negative 5, 8, 3, 3, 4, 5, and 8, 3. So in this case, we can see a repetition of the y coordinates 3. But in terms of the x coordinates, no repetition or the x coordinates were used once in every ordered pair. We have the what we call many to one correspondence. Then, according to the definition, same y coordinates with different first coordinates is permitted in a function, even though the y coordinates is repeated twice as long as we have a unique x coordinates paired with any member of the range, still it is a function. Always remember that correspondence of functions are one-to-one correspondence and many-to-one correspondence. Hence, the correct answer is option A. So we have the set containing the ordered pairs 3, 2, 4, 3, and 5, 2 with the correspondence many-to-one. Item number 11. What is the simplest form of the rational expression 2 raised to negative 5, x raised to negative 2, y raised to negative 1, all over 8 raised to negative 2, x raised to negative 1, y raised to negative 2? The options are A, y raised to 4 over 2x raised to 7th power. B, y over 2x. C, y raised to 4 over 4x raised to 8th power. Then D, 2y over x. In simplifying negative exponents, we may consider the following. If m and n are integers and a is not equal to 0, then a raised to negative n is equal to 1 over a raised to n, and also 1 over a raised to negative m is equal to a raised to m. Or simply, we just move the term with negative exponent from numerator down to the denominator. If it is placed in the denominator having a negative exponent, to make it positive, we move it into the numerator. Then let's proceed with the item. 2 raised to negative 5, x raised to negative 2, y raised to negative 1, over 8 raised to negative 2, x raised to negative 1, then y raised to negative 2. To make all of this negative exponent positive, we interchange the places of the numerator to the denominator, then the denominator to the numerator, making all of their exponents turned into positive. So we have 8 squared x y squared over 2 raised to the 5th power x squared, then y. Now, as you can see, we have 2 raised to the 5th power on the denominator. Then we all know that 8 can be written as in the base 2 with the power of a power law. We have 2 cubed quantity squared. Then we can say that 2 cubed squared will be equivalent to 2 raised to the 6. Then with the use of the quotient law, we subtract the exponent. We have the final answer, 2y over x. Always use the law of exponent in simplifying the rational expressions as stated earlier. Hence, the correct answer is option D, 2y over x. Item number 12. Which of the following is a polynomial in x? Options are A, x raised to negative 3 plus x plus 2. B, square root of x minus 5x plus 1. C, x cubed minus 4x plus 2 raised to negative 1. Or D, 5x plus 2 over x plus 2. By definition, a polynomial is a term or a finite sum of terms with only non-negative integer exponents. Again, a non-negative integer exponents permitted on the variables. If the terms of a polynomial contain only the variable x, then the polynomial is called polynomial in x. Some examples of polynomial in x will be x cubed minus x squared plus 2x plus 4, since all of the exponents of the variable x are non-negative integer. On the second example, we have 4x squared over 5 minus 5x plus 3x squared plus 2. Remember that not polynomials if the variable has a fractional, radical, or negative exponents or the variable is in the denominator. With the given options on this item, we can simply say that C, x cubed minus 4x plus 2 raised to negative 1 qualifies to be a polynomial in x. Item number 13. What is the solutions of the system of linear equations? 2x plus y is equal to 8 and negative 20 is equal to 4x plus 2y. The options are A, 2, 4, B, infinitely many solutions, C, no solution, D, 0 is equal to 0. In finding the solutions of the system of linear equations, we may use elimination method, then the substitution method. First, we need to arrange our equations vertically, just like with this one. We are having it written as 2x plus y is equal to 8, then negative 20 is equal to 4x plus 2y. Now, next move is to rearrange our second equation similar with the placement of the x and y's on the left side on the equation 1. So we are going to write 4x plus 2y into 4x plus 2y in the left. Then we have negative 20 on the right side of the equation. We just simply interchange them. Now, let's observe the variable to be eliminated. Now, if we look at x, we have 4x here. Now, on the first equation, we have 2x. To make it a negative 4x, that is enabled us to eliminate the x, we multiply negative 2. So that is, we have negative 4x, then a negative 2y is equal to negative 16 through distributive property. Then we just copy the second equation. 4x plus 2y is equal to negative 20. Then we proceed with adding the similar terms. We have negative 4x and 4x, it is equal to 0. Now, if we have negative 2y plus 2y, again, it is equal to 0. Then 0 will be placed at the bottom here. Now, if we have negative 16 and negative 20, we are going to add them. We have negative 36. Can we say that 0 is equal to negative 36? No. So, we can say that 0 is not equal to negative 36. Therefore, there is no solution to the system of linear equation. It is an empty set. The system of linear equation will be an inconsistent system. Okay, always keep in mind, in using elimination method, our goal is to eliminate one variable in the equations as to solve the other variable. Hence, the answer to our item is C, no solution. Item number 14. What is the graph of the system of linear equations 2x plus y is equal to 25 and x minus y is equal to negative 10? The options are A, intersecting lines, B, coinciding lines, C, parallel lines, D, skew lines. We can also determine the graph of the system of linear equations by solving for its solution. Again, we arrange the equations vertically. We have 2x plus y is equal to 25, then x minus y is equal to negative 10. As you can see, we can easily eliminate y since we have a positive and a negative y here. That is, we cancel it out since it will turn into 0. Then we proceed by adding 2x and x. We have 3x. Then 25, negative 10 will be positive 15. Then we divide both sides by 3 as to eliminate 3 here. Then we have x. 15 divided by 3 will give us 5. Since we have 5 as the value of our x, we can now proceed with substitution. So, we may choose any of the equations in our system. Then we choose to have the second. So, in the second equation, we substitute 5 minus y is equal to negative 10. Then we simplify it. Then it is now equal to 15. Thus, the solution is 5, 15, which implies that the two equations intersect at point 5, 15, with an intersection point it is a clue that the two equations is a line that is intersecting. Hence, the graph of the system of linear equations are intersecting lines. To show you the graph, actually, we can also graph it. Then we can see that they are intersecting lines. So we may use the table as our guide. For the solution having an ordered pair, we have a graph which is intersecting lines, and the type of system will be consistent, independent system. Hence, the correct answer is option A, intersecting lines. Item number 15. What type of system are the following linear equations? X minus 2y is equal to 7 and negative 21 is equal to negative 3x plus 6y. Options are A. Consistent independent system, B. Consistent dependent system, C. Inconsistent system, and D. Inconsistent dependent system. Again, we solve for the solutions of the equations. We have x minus 2y is equal to 7, then negative 21 is equal to negative 3x plus 6y. Then we rearrange our equation 2. We have negative 3x plus 6y is equal to negative 21. By observing the x variable with the numerical coefficient, which is negative 3, we just simply multiply 3 on the first equation just to have it eliminated, the variable x. Okay, we multiply 3 here, then we end up with 3x minus 6y is equal to 21. Then we copy the second equation, negative 3x plus 6y is equal to negative 21. Then we proceed with adding them. 3x minus or 3x negative 3x will be 0. Negative 6y plus 6y will mean 0 also. Then 21 negative 21 is equal to 0 also. Then we have this 0 is equal to 0. Thus, the solution is infinitely many. If we set x is equal to 0, our y by substitution will turn into negative 21 over 6, wherein 0, negative 21 over 6 is a solution to the system. But if we set x is equal to negative 1, then our y is equal to negative 4. Thus, negative 1 and negative 4 is also a solution to the system. Meaning, since we set infinite values of x, then there are possible infinite values of y. Thus, infinite number of solutions or ordered pairs are there. Hence, the system is consistent dependent system. With the table, we can see that if A is equal to B, then there will be an infinitely many solution. Then our graph will be a coinciding lines. Then the system will be classified as consistent dependent system. Therefore, the correct answer is option B, consistent dependent system. Item number 16. What is the solutions of the system of linear equations negative 4x plus 2y is equal to negative 16 and 2x minus y is equal to 8? The options are A. 2, 4, B. Infinitely many solutions, C. No solution, or D. 0 is equal to 0. Solving through elimination method, again, we write our equations vertically. Negative 4x plus 2y is equal to negative 16. Then we have 2x minus y is equal to 8. Then, we can see that in order to pattern 2x minus y is equal to 8. To the first equation, we multiply 2 to the second equation. So we have 2 being multiplied to the second equation will turn into 4x minus 2y is equal to 16. Then we have this. Copy the first equation, negative 4x plus 2y is equal to 16. Then the second equation will be 4x minus 2y is equal to 16. We use the distributive property wherein we distribute 2 to the both sides of the equation. Then we proceed with adding. So if we have negative 4x and 4x, it will turn into 0. Then if we have 2y minus 2y, we have 0 also. Then if we have negative 16 and 16, we also have 0. As 0 is equal to 0 will mean a solution is infinitely many. Since if we set a particular value of x, then we will end up with a particular value of y. That is through substitution. So meaning, since infinite values of x are possible, infinite values of y exist. Thus, infinite number of solutions, ordered pairs are there. Hence, the system of linear equations has infinitely many solutions. Therefore, the correct answer is option B, infinitely many solutions.